Good morning, ninth standard, and today we are going to start chapter number 3, that is atoms and molecules. But as you know, the chapter name, that is atoms and molecules. So the main objective of this chapter is that in this chapter we are going to study about that what is atom, what is molecule, what is ion, what is compound, and how we can write down the formula of a compound, as well as what is the law of chemical combination, in which we are going to study about the law of conservation of mass, law of constant proportions, and uh, from where the definition of atom is come. That means a Dalton atomic theory. So these are the main basic objectives of this chapter, as well as we also study about the mole concept in this chapter. Fine, beta? So it is a very, very important chapter. और अगर हम बात करते हैं कि why there is need to study about this chapter, so yes, can atoms and molecules. So from, if we are talking about that, if we see at our home also, there are many particles, or we can say there are many objects lying, or we can see in our surroundings, like books, pen, pencil, paper. ठीक है, अगर आप सिर्फ किताबों की ही बात कर रहे हैं, अपनी पढ़ाई की ही बात कर रहे हैं, so regarding that also, so all these book, but bag, your pen, your eraser, that is also made up of a very, very tiny particle, and all those tiny particles are known as atoms. ठीक है, हम उन्हें क्या कहते हैं? Atom. So atoms की जो beginning discovery है, that is not started recently. From our ancient Greek and Indian philosophers, they were also wondering about this, and they were also working on this unseen form of matter. ठीक है? The idea of divisibility of matter. Can matter be further divided into a smaller particle? So that idea also come long back in India, and that is near around 500 BC. There was an Indian philosopher that is known as the Maharishi Kannad, and who postulated that if we keep on going dividing a matter, or we can say the padarth, that from there we get smaller and smaller particles, and ultimately अगर हम उसको divide करते जा रहे हैं, हम पर क्या मिला जा रहा है, हमें smaller and smaller particles मिल रहा है, then there definitely a stage will come when we come across the smallest particles, which is beyond further division, and that smallest particle was known as परमाणु. तो महर्षि कन्नड़ ने उस मैटर के स्मॉलेस्ट पार्टिकल को, जो कि फर्दर डिवाइड नहीं होता है, that is known as परमाणु, या उसको नेम्ड किया था परमाणु. There was another philosopher also, that whose name was Pakudha Katyayama. He basically said that these particles normally exist in a combined form. Which particle? परमाणु. परमाणु जो है वो किस में होता है? Combined form में exist करता है, and that gives us the various forms of matter. ठीक है बेटा, जो कि हमें क्या देती है? Various forms of matter देती है. So around in the same era, उसी timing में, ठीक है, there was a Greek philosopher who named as who named as the Democritus. ठीक है, and Democritus and Leucippus, both of they also suggest that if we further keep on dividing a matter, then there must a stage will come which after further division, when their stage, a final stage will come where no more division can take place, and Democritus called these indivisible particles a atom. ठीक है, तो Democritus ने ये नाम दिया था, which is atoms, and atoms means indivisible particle. Indivisible, जो कि क्या है, further divide नहीं हो सकता. So all these Democritus, Lysippus, Katyayama, Pakudha Katyayama, and there is Sage Maharishi Kannad. All these was based on just a philosophical considerations. There was no experimental work to validate about these परमाणु findings. ठीक है, and so till in 18th century, or we can say by the end of the 18th century, the scientists gradually recognized the difference in between the elements and the compounds, and naturally that became interested, they became interested in finding out how and why the elements combine and what happened when these elements combine. ठीक है बेटा? So for that, there was the first of all, the law of chemical combination they studied. So there was the two laws were established after the, just 1 minute. Yes. After the experiments of Lavoisier and Joseph L. Proust. Okay, so law of conservation of mass, that was the first law, and according to this law, just in naam se pata chala, conservation of mass means mass remains conserved, mass remain constant in the product as well as in the reactant. Mass can neither be created nor be destroyed during a chemical reaction. ठीक है, तो ये उन्होंने कहा था. So he just performed an activity for the proof of that, and please just consider this, that they have taken two sets of chemical, that is X and Y. In X, he has taken a copper sulfate. First condition, just have a look, that he take a conical flask. First of all, I will explain it with the help of one setup. Like he take a copper sulfate of 1.25 gram, and the another as a Y, he take sodium carbonate in 1.43 gram. This is the mass which he has taken of copper sulfate and sodium carbonate. So first of all, they prepare a 5% solution of copper sulfate and 5% solution of sodium carbonate. Okay, 5% means that take 95, suppose 95 proportion of copper sulfate, sorry, 5 proportion, 5 unit of copper sulfate and 95 unit of water. ठीक है, तो because you have to prepare a solution, it means that you have to add water in the copper sulfate and prepare a solution. Similarly, sodium carbonate, add water in it and prepare a 5% solution of that. So for 5%, you have to just take 5 units of copper sulfate and rest amount is of water. Similarly, 5 units of sodium carbonate and 95 amount or unit of water in it. Then that will become a 5% solution. Listed again, X and Y each in 10 ml in water. Okay? So 10 ml in water में ले लिया. Now take a little amount of, first of all, take a little amount of Y in a conical flask. कहाँ डाल दिया? Pour little amount of Y means sodium carbonate in conical flask. ठीक है, conical flask में डाला, and then some amount or solution of copper sulfate in ignition tube. There is a very small tube also, you can see here. First, he has taken the sodium carbonate solution in conical flask. Then he take a small solution of copper sulfate in your ignition tube, which is a very small tube, and then hang the ignition tube in the flask as shown here in the figure. Similarly, just tie the ignition tube with the help of a thread and uh, put the cork on the conical flask and hang the ignition tube in the flask carefully. Then at this time we have to see that the solution do not get, both the solution do not get mixed with each other, and put a cork on the flask as shown in the figure. This is a figure, as you can see here, it is a cork, then there is a thread which holds the ignition tube, and there is a conical flask. It's a small ignition tube in which there is a copper sulfate solution, and X is the solution of copper sulfate and Y is the solution of sodium carbonate. Okay, beta. Then after that, just weigh the flask with its contents carefully without mixing both the solutions, without mixing copper sulfate in sodium carbonate. Weigh the flask. Okay, so it will give you the mass of copper sulfate and sodium carbonate total. De dega. Then now tilt and swirl the flask. Just tilt the flask and swirl it, means just shake it so that the sodium carbonate and copper sulfate solution get mixed with each other. Then after that, again, because we already closed the flask, then again weigh the flask. Then after that, what happened in the reaction flask? Obviously, a chemical reaction take place in the reaction flask, and the double displacement, both the solution, they get mixed with each other. Yahi hoga beta. Both the solutions will get mixed with each other, and then after that, when we weigh it, we come up to the observation, then the weight of the flask that remains same, means total mass before reaction starts, total mass of the reactant is equals to the total mass of the product. The mass was not changing after taking place of the reaction also. There is a one more question. Why should we put a cork on the mouth of the flask? क्यों लगाई बेटा? If we do not put a cork on the mouth of the flask, then if there is a formation of a gas in any one case, ठीक है, अगर gas बनती, then it will released and mixed in the atmosphere, and then obviously the gas mass will be decreased or deduced from the flask. Does the mass of the flask and its content change? No. The mass of the flask, that will not change. Its contents change. Yes, its contents chemically changes, because the first of all, we have, as we have taken copper sulfate plus sodium carbonate, then it will become the copper carbonate and sodium sulfate. But the volume of the content will not change. Content will remain same. Mass of the flask will remain same. So if from here we can prove that the law of conservation of mass says, yeah, states that mass can neither be created nor destroyed in a chemical reaction. So beta, today we have done about the law of conservation of mass. You just read it again once again from your book. Thank you.